Okay, so we're going to solve each polynomial by factoring. The fact that our directions have the word solve, this is important, means that you're solving each equation. So sometimes the word equation is there for you. Sometimes, well, I don't have to put a period. Sometimes it'll just say solve, period, end of story, right? So you have to assume if they're asking you to solve, they're asking you to solve an equation. If they're just asking you to factor, they're asking you to factor an expression. But we're even being really specific, and we're saying to solve by factoring so that you know what method we're going to use. So this is what we were doing in class yesterday. In Algebra 1, you did solve a certain type of equation by factoring. What kind of equations were they that you guys solved by factoring? We reviewed it this year, not too long ago, right in December. We reviewed solving something by factoring. Starts with a funny letter of the alphabet, a rare letter. We don't use all the time. Yes, quadratics, good. We solved quadratic equations by factoring because those are the first things you learned how to factor, right? So the first one we're going to do, it's actually number 5. And number 5 says what? Armand, can you read it to me?
X cubed plus 3x squared plus 2x.
I'm sorry, say again. X cubed plus?
X cubed plus 3x squared plus 2x equals 0.
Nice. Okay, thank you. What kind of a polynomial is this? Well, if it's x cubed, what's the name of the type of polynomial? Cubic. And if it's got 3 terms, so you could even say it's a cubic trinomial. Sure. So we could call this a cubic trinomial if we want to. And it's equal to 0. When we see this equals 0, if you remember, at one point I think I drew a good goofy looking smiley face on these. So if something said equal to 0, we're happy because we can solve. We solve this using something called the zero product property. Zero product. What operation are we implying we're talking about if we use the word product? Multiplication. Multiplication when you were a kid was represented by a little x, right, to multiply. Then we got to a point where we started using a dot, or we used what else for multiplication? Parentheses, yeah. So when we're all factored and separated by parentheses, that's really saying we have a product. Bunch of factors. And 0, well, that's the 0 we're talking about, and it's a property because it's going to tell us what to do. All right, factoring methods. Which factoring method do we always try first? Josh, which factoring method should we always try first? Good. Greatest common factor. Is there a greatest common? No. Sometimes the answer is going to be no. Is there a greatest common factor in this example, Jay?
Yes, x.
Good. It's just x. Perfect. So we're going to try to take an x from everybody because it's the biggest they can all offer us. Now, if you wanted to show work for yourself because you struggle, that's fine. You write an x underneath a line, and then we bring it out front and put parentheses, similar to the little song we have, but we divide out an x because factoring is undoing distribution, and distribution usually associated with multiplication. So if I divide each of these out, it won't really be a pretzel. It's going to be more like a peacock if I draw these little ovals. What is x cubed over x, and then 3x squared over x, and 2x over x? What's left inside? Nafia, what do I get inside here? Yes, x to the second. 3x, because x squared meant I had 2 x's up there. Good. Good, because the x just reduced out. Now, this over here is just plain x, okay? Yesterday, I compared plain little x equal to what character? That's Baby Yoda. Yeah, he's walking around. There's 2 little legs, and he's walking around because his pod is out of commission right now, his little floaty pod spaceship thing. But we're going to keep him safe, and we're going to build him a new pod. Okay, so we're going to put him in a pod so we don't forget about him. There he is. Now here, I still have a trinomial in here, but what kind of trinomial do I have inside now, Sam? What kind of trinomial is this? This was a cubic trinomial, but what's this one? Do you remember the name? It's not a square trinomial. We've used the word before. Do you remember what kind of trinomial this is, Gabby? When it's x squared, you know the words for this. Nicole, what kind of a trinomial is this for x squared? What's the word? You guys are all going to feel very silly because you know this word better than the rest.
Quadratic.
No, that's for 4, my dear. Thank you. Quadratic.
That's what I was thinking.
Sure. So here's the x. Now that's a quadratic. Do you know how to factor this quadratic?
Yes.
You could use a couple different methods.
AC method.
Sure, we can use AC method. Cairo, I'm going to use the AC method. What's A times C for this example? What's A?
X squared.
No, a is in front of it. Look, ax squared, we write like this, plus bx plus c. Am I cut off or am I on the screen? I'm good? Okay. A is really 1, and c is 2. And 1 times 2 is obviously just 2. Then once you get your AC, what do you do next? Yeah, the multiplication of factors, right? So 1 and 2, because 2 is prime. And then I underline it again. What do I put underneath the line, Jahari? In the factoring process, every time I do this with you guys on the side, AC method, I do AC on top. And what goes on bottom? B. B for but. But what? But they need to multiply to give me 2, but they need to do what else? Add to give me, in this case, positive 3. Good. So positive 2 and positive 3. Well, what two numbers? Are any of them going to be negative? No, they're both going to be plus. Then we use this. Armand, what was the name of this type of trinomial again? No? Quadratic. And quad makes you think of what number? 4. But how many terms do we have? So we do build a quad. Quartic is talking about the 4th power. We are going to build a quad. We leave the first and the last, and we split the middle up using these two numbers, right? So I'm going to have x squared, then I'm going to use these, plus 1x, plus 3x, plus 2. Yep, I meant to write that, thank you. I felt like I did, but I was looking at those next two. All right, there it is. Now that I'm like fully pushed into the AC method over here, I can now use another method technically. What method can I use? Grouping. Underline, underline, greatest common factor. What's the greatest common factor over here? Gabby, you know this one? X. What's my greatest common factor over here, JR? 2. But I put with the 2, I put plus or positive. Good. So, because it gets a little bit hard to see, because like you'll have so many parentheses once we really start factoring, what I'm going to do is I'm really just going to make these parentheses that are here, just because I have a highlighter handy, I'm going to go and make them really bold, so that in the next step I'll still have them, but I'm going to have other parentheses inside, okay? So I'm just going to push this up a little. Let's go over there so we can see a little bit better, okay? All right, so we started this song thing. Underline, underline, greatest common factor. What happens next? Bring it out front. Bring it out front. What happens next? Parentheses. Good. Then, what do we do next? Not yet. I took a brown pen out because I'm going to draw my pretzel. 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 If that sign's not there, it's going to mess up this parenthesis. Pretzel, pretzel, what goes inside? If I divide this, Aaliyah, what goes inside of this one? X plus 1. Over here, do we get x plus 1 again this time, Sam? Yeah, so we're good. The next line of the song would have been, if it matches, you're winning at life. Now, really, I'm going to go over here. Oh, no, that's not that x. I'm sorry. So this x was the one I took out front. I'm going to show you where this one came from because it kind of, I thought it was Baby Yoda for a second. This x right here, I'm just going to color it. I know it's bright, so you might not see the yellow too well. But that x is that one right there, okay? Because there is going to be another x floating around, right? Guess what color I'm going to make the x on the outside? Yeah, you guessed it, for Baby Yoda. So this x over here is a separate one, okay? We don't want to mix them up in the middle of the problem. So this one is x over there. Now, if it matches, you're winning at life. Bring it out front. In front of the yellow one, really. It doesn't actually matter because multiplication is commutative. So here's x plus 1. And then, if it matches, you're winning at life. Bring it out front. What's left inside? Good. Is this fully factored now? Yes, okay? Yes, it is. Now, all along the process, we really should keep equals 0 on the side because it does still equal 0. We don't change that. So now we're going to really bust out this 0 product property. So do I have everything written as a nice product? Yes, factored form means that you have a nice product. 0 product property means you're going to set each inside, okay, the inner part of the parenthesis, each one equal to what number? 0. It only works for 0. So this one is essentially finished. Now you're going to see I'm always going to do these horizontally. Do not do them vertically. Do not stack them on top of each other. That's useless for us, okay, Armand? So x plus 1, I'm going to set that equal to 0. and x plus 2, going to set that equal to 0. If I have this one, well, this one's already finished. Here, I'm not done. What do I need to do next for this one? Subtract 1 from both sides. So Jeremiah Ricks, what do I get for this one? X equals? -1, good. -1, I'm just going to box that. And then over here, what can I do next? Avery, what should I do next for this one? Or maybe Jeremiah M. Avery. Jeremiah M, can you tell me what to do for this one, though?
Subtract the 2.
-2 from both sides, right? And what do I get for my answer for it then? X equals?
-2.
Nice. Okay. Now, when you solve by factoring, let's talk about the rules. So, if it says solve by factoring, first thing is your equation must be equal to what number? 0. If it's not equal to 0, that's step 1. Get your equation equal to 0. Step 2, you have to do what? Factor it. And always make sure it's fully factored, okay? Make sure it's fully factored. And then, after that, you could apply the zero product property, which is you taking each thing and setting it equal to 0. Now, how many answers did we get for this question? 3. Okay, we're going to see something in common over here. So one way to kind of confirm your work, taking on another highlighter. Over here, we see that my biggest exponent is what number? And how many answers do I have? I have 3. That is not a coincidence. We have 3 answers, and my biggest power is 3. That's a way to check your work. There are some weird fuzzy spots for some of them because a number can be an answer twice, and that can be a little tricky, okay? So that is the end of number 5. Now, you could write it twice or write it once. It doesn't really matter. Really, we write it once, but yeah, because you would, if you ask for the roots, you would list it more than once. If you describe it as a 0, what are the zeros of something? Do you remember what zeros are? When you find zeros, you're finding it's a part of a graph. Not the vertex. No, it's the X-intercepts. Okay, the vertex, the zeros are your X-intercepts. If you guys look over there on that little clothesline above Avery, right? Avery. So above Avery's head, you see, it's got to get colored in a couple of the letters because I ran out of stickers, so I drew them. But do you see X-intercepts, solutions, zeros, roots? I put those words together because they go together. A lot of times they mean the same thing. So I hung them up on the wall for you or in the room so that we remember those words go together. Now, side lesson, bonus lesson, not full, but I'm going to give you a little sneak preview. The directions normally set to solve by factoring. I'm sorry, solve by what? Graphing. So 1, 2, 3, 4, 1, 2, 3, 4. So we're going to do this later on, but here's -1, here's -2, and here's 0, right? When we start solving by graphing, or actually just graphing polynomials, the numbers we get as our zeros, I just said these are your X what? Yes. These are the X-intercepts. Okay, so those are my X-intercepts all plotted. Now, you don't fully understand why all the way, but I'm going to give you a little bit of a peek. See that my equation starts off with a positive term? Okay, so analogy we can use. If you're positive, just think like, if I'm positive, I'm going up in life. So this is it going up. And then all you do for now, you're just going to draw a graph, kind of squiggling through those points, and that's your graph. Okay? So that's your graph. So if they say solve by graphing, it's because they're asking you, it's sort of like solving a system of equations. Where does this equation or graph equal 0? And 0 is the x-axis. So where does it equal it? At the same 3 points. But like I said, I'm just going to show it to you now so you could just be exposed to it a little bit before we learn it. But I think you'll think this is pretty easy. Okay? All right. Next example, I think we said skip 6 and then it was 7, 8, 9. Yeah, I said 5, 7, 8, 9. Because I wanted them to be like a little nicer to factor. So number 7, can you read number 7 to me? Does Avery, you have the book open? Go ahead, 4x what? Thank you. Plus, what? Say what? I think it says, oh, you already did the next step. So I'm going to do the step before. I think it said equals 4x squared plus 3x. So you just told me, and this is number 7. I don't know if I'm on the screen good right there. Okay. So Avery, you just told me the next step. So Avery brought these 2 terms to the other side. How did he do that? What operation did he use? Yes, he used subtraction. So 4x to the third minus 4x to the second minus 3x. But you don't just lose your equal sign. It equals 0. So Roy, go ahead.
Is it the same thing if you
If you subtract 4x cubed from both sides, yes. The problem is a lot of times you guys do weird things when you're leading terms negative. You get weird with factoring. So I always try to make sure the one with the biggest power is on the side where it's positive. You're not wrong. You could still get the same answers. Okay? So we're over here. So Soroya, what do we say? Which method do we use to start factoring all the time? We always try something first. Yeah, GCF. Is there a GCF here, Sahai? How much? Just VX? Is that, or did you say 3x or x? Just x. Yeah, 3x, even though like 4 has a 3 in it, it's not divisible by 3, right? So an x can come out of everything. If I take an x out of everything, then what's left? Emerson, what do I have inside? What's my quadratic trinomial going to be? 4x to the second minus 4x minus 3. Good. Now we have a quadratic trinomial. So Cairo, what do I use to factor a quadratic trinomial? How should I get this started? What method? I have a poster full of methods up there. AC method. Sam, question or comment?
Question.
Go ahead.
Do we have to set it to 0 even though it doesn't say that in the original question?
So that's what we were saying. So when you go back to this example earlier, I said step 1 to solving a polynomial equation, step 1, get it equal to 0. Because then we can't use the zero product property. Zero is special, so like that's why we're allowed to set each factor equal to 0, because other numbers won't do that. Like if I say I have 3 things being multiplied, is it possible that all 3 equals 0 and they still multiply to 0? Yes. But is it possible that this equals 2, 2, and 2 and it still multiplies to 2? No, because 2 times 2 times 2 is 8. So like it doesn't work with any number except 0. So that's what makes it solvable. Cairo, question? Go ahead. All right, so we're going to solve by AC method. AC method obviously means you got to find AC first. Moreau, what do I get for A and C? What's A value and what's C value?
4.
And C is? So Jeremiah Ricks, what do I get when I do 4 times negative 3? Good. Yep, negative 12. Positive times negative is negative 12. Then we make our list of what, Josh? We multiply AC. We're doing AC method. Now, I got negative 12. Underneath the line, what do I do? We ordered, not ordered pairs, but pairs of factors, right? Yes, pairs, but yes. 1 and 12, right? 2 and what, JR? 2 and, to make 12? 6, and 3 and what? 3 and 4, good. Now, underline it again. What goes under the line, Aaliyah? B what? B for but what? A x squared plus bx plus c. A, c, got us the top. B for but what? But b equals negative 4. So I have to pick a pair of factors that multiply to give me this, but add to give me this. So Nafia, what 2 numbers should I be picking? 3 and 4 add to give you negative 4? Well,
Or we negative 6 and positive.
negative 6, good, and positive 2. The one way I told you, some of you guys are good. You know your positives and negatives, and even or your positive and negative rules. If you struggle, if you're going to be negative and you're going to have one of each parent, okay, you're going to inherit your negative gene from the bigger parent, right? 6 is bigger than 2, and you inherited the negative, so 6 is negative and 2 is positive, okay? So Sam, now that I know which 2 numbers I'm going to use, how do I set up my next step? I want to take care of this. So I'm putting this out front.
Yeah, and you get 4x squared
4x squared, yes.
plus 2x
Plus 2x, good.
minus 6x
Minus 6x, nice.
minus 3.
Good. So there's my quad that I put together. First step for the factoring song. So hi, how does it start? Did you write it down? Why not? You didn't want extra credit? You should have earlier. What are the first 2 steps? If you didn't do it before, write it down now. Jay, what are the first 2? Good. First 2 words are underline, underline. Because I'm going to have parentheses inside of them, and I don't want to get confused because I have the X on the outside. Underline, underline. What are the next 3 words? Jeremiah M. Underline, underline. What do I say next? Good. What is the greatest common factor, Emerson, underneath here? Over here, Nicole? Nope. No x. Not just 3. Yes, -3. Underline, greatest common factor. Josh, do you know the next part? Underline, greatest common factor. Good. Bring it out front. Here's that x all the way out front hanging out. Here's my brackets. Jahari, what do I say next? Underline, greatest common factor. Bring it out front. Good. Parentheses. Moreau, what do I say next? Underline, greatest common factor. Bring it out front. Parentheses. Look at what I'm drawing for you. I'm drawing you a beautiful picture. Pretzel. What do I say next, JR?
What goes inside?
You're not JR.
Oh, sorry.
Did you get confused? All right, so JR, what goes inside of this? Well, 2x over 2x is really good. And then over here, -6x over -3. We get the same thing? Do we still get that? I'm not going to use pink. It's a little light. So 2x plus 1. Here I get it again. 2x plus 1. So pretzel, what goes inside? Sahai, do you remember what I say for this part when I do the squiggle? Told you guys, I'm not a songwriter. It's like the worst song imaginable, but Aaliyah, do you remember? What do I say when I do this squiggly underline? Yes, if it matches your winning at life, bring it out front. So here's the little baby Yoda x. Here's the bracket. I'm going to bring that out front. So that's 2x plus 1. I brought that out front. And then usually on the board, I'll cross it out because I brought it out front. And then I ask you guys. What do I ask you? Come on, guys. Second time I asked the question.
What goes inside?
Thank you much. 2x minus 3. Now these brackets are no longer really necessary. They were only really necessary in these 2 steps while we were doing the factoring process. So if I want, I could just write x and 2x plus 1 and 2x minus 3 equals 0. And really it should be equal to 0 the whole time. So we said factoring polynomial equations. First, get the equation equal to 0. After that, solve by factoring. Bust out all your factoring methods. Always try what factoring method first? Thank you. Now, we got it all factored. We ended up using GCF. We ended up using AC method. We ended up using grouping. It's factored. Now we're going to apply the what? Which essentially tells us take the inside of each piece of the product and set it equal to 0. X equals 0. 2x plus 1 equals 0. And 2x minus 3 equals 0. Then we solve each one. This one's finished. Done. Here, I'm going to subtract 1, right? Minus 1. I'm squeezing it a little because I run out of paper here. 2x equals -1. Not done, though. Draw a little arrow. 2x or x equals. Thank you. So x is -1/2. That's a -1. Sorry, my ones are a little rough. Okay, and then over here, I said, so I'm going to box that up a little bit. You guys are copying this, I said, because I'm collecting. I want to see that you copied it perfectly. And then this one, 2x minus 3 equals 0. First thing we do to both sides is, thank you. So we get 2x equals 3. And then we get x equals? All right, here, big question of the day, because everyone in the Honors Algebra 2 is messing this up for me. What's 3 over 2 as a decimal? 1.5. Is Armand correct? So when it's over 2, what's that another way of saying? Divided by 2, when you divide something by 2, you're also finding how much of it? Yes, and what's half of 3?
1.5.
Half of 3 is 1.5. Yep. Now we got 3 answers. What did I tell you guys to look at the beginning of the problem? Yeah, and what was the biggest power? And that looks good to me. Now, if I wanted to show you again, remember, I'm showing you the whole experience of, graphing this, solving by graphing. So while some of you might be still copying, I'm just going to draw a little bit more graph. I'm going to go 3 tick marks this way, 3 tick marks this way. My solutions are also what's the Z word? Z word. My solutions are it's on the clothesline.
Zeros.
Zeros. And zeros are your what?
Root.
Roots. What else?
Intercept.
X-intercepts. So my X-intercepts are 0. Which way do I go for negative 1/2? Left or right? So I go a half this way, right? Negative half, because that's negative 1. And negative 2, negative 3. And then I also have positive 3 over 2. So that was negative, a little hard to see. So 3 over 2, you guys told me is what number? Between what and what?
1.5.
So it's between?
1 and 2.
Good, it's right there. Now my equation's positive in this case. Where is it? Right there. My equation's positive. So that means my graph finishes where? Going up. And for now, until you learn the full lesson, we just draw our little squiggle, cutting through it all my x-intercepts, and we call it a day. So do you see it's like a parabola, but bendier?
Yeah.
Like a parabola just bends one time. As the power gets bigger, like third power, fourth power, it's just going to bend more, okay? This video is going to be on Classroom in a few minutes, okay? Next example, we have 2 more, and I think we can move much faster now. Can somebody read me the original problem for number 8? Who hasn't spoken to me much today? Soraya, I haven't heard from you for a minute. So can you tell me what the number 8 was? Hey guys, so in this example in class, I actually made a mistake in my work, so you have to stay tuned till the end. But hopefully you catch the mistake yourself and you correct it as you go, and then you don't have to worry about making any correction at the very end. But if you have the same mistake on your paper because you already copied it, then we'll just fix it at the end together. 2x to the 4th?
Yeah. Minus 5x cubed.
5x cubed.
Minus 3x squared.
Good.
Equals 0.
Nice. All right, guys. GCF. What's my GCF in this example? X squared. Nice. Kyra, if I take an x squared out of everything, what's left inside?
2x squared minus 5x
Good. Equals 0. Now inside, we call this again a quadratic trinomial. It's only second power there. We're going to do AC method. I'm going to do it a little faster. AC. 2 times negative 3 is negative 6. Factors are 1 and 6 and 2 and 3. Underline it again. B for but. But what? But it has to add to negative 5. Here's sneaky. Do you see how 6 and 1 could give me 5? And so can 2 and 3? Okay, let's check them both. If I use 2 and 3 to get negative 5, what signs are they? Good. If I use 1 and 6 to get negative 5, just a negative 6 and a positive 1. Now, here's how you decide. They have to multiply to be negative 6. Which one multiplies to give you negative 6? Right, because this one gives you positive 6 because it's a negative times a negative. So watch out. There's those sneaky curveballs sometimes, So those are my 2 numbers, x squared. Now, here's Baby Yoda's pod. Do you see I put the 2 on the outside? Only x is in the pod. Only x is in the parenthesis. Okay? Why do I say ridiculous things like this? It's because when we do the real method for factoring and for graphing these, it's going to matter. That's why, okay? So I know it sounds silly now. I promise it'll matter later. Just like I told you how to factor quadratics with grouping because we use them on all polynomials. I want you guys to learn methods that work and are like really good to use all the time. So I'm going to build the quad. Here's the bracket. I have 2x squared, and then I have plus 1x minus 6x minus 3. Bracket is 0. Underline, underline. Greatest common factor. What's the GCF? X for that one. And for this one, what is it?
3. Negative 3.
Negative 3. Good. So here's the x squared sitting out front. Here's the bracket. I'm going to bring out the x, bring out the negative 3, parentheses, parentheses. If I do a pretzel, Jeremiah M., what's left inside for both of these if I do the pretzel step?
X plus 1.
X plus 1, and that one works as well, so I know I did it correctly. If you picked these 2 numbers instead by mistake, they would not match, you would not be winning at life, and you'd have to start over or use quadratic formula. So if you cannot factor a quadratic, what do you use to solve it? Quadratic formula. If you cannot factor a quadratic, use quadratic formula, okay? Then from here, if it matches, we're going to bring it out front. So here's the x squared. I brought forward an x plus 1. What's left inside? Nice. Now, if I set my insides equal to 0, I'll get x equals 0. Because what property am I applying?
0, 5.
Good. So I get x equals 0. That one's done. X plus 1 equals 0. And x minus 3 equals 0, right? Yes.
What do you do
So right now we just set the inside equal to 0. I'm going to tell you what that means in a second because it's going to tie all together. So I subtract 1, I get -1. I add 3, I get 3. So are you guys okay with this part so far? Now, Soraya asked about the 2, and I'm glad she did. The 2 tells me I really have 2 baby Yodas because it's squared. I have 2 of them. So if I want, I could really do this. Another one. You don't really have to because can you have the same x-intercept twice, really? I mean, not if it's a function. How do you cross through the same spot 2 times, you know? So it's kind of like if I said to you, can you go through the doorway twice? What would happen? You're in the classroom, and I ask you to go through the doorway twice. What happens? So you end up back in the room, right? So you're not going to get the full lesson on this now. I'm just showing you, but this is what would happen in the graph because of the double 0 over here. No, it is, but we have an interesting way of drawing it. So 1, 2, 3. Here's 3. And then here's the -1. Now the graph is positive, right? Positive 2x to the 4th. And it's also 4th power. So how many answers should you have?
4.
So do you see why we have 4 answers, really? Okay, so that's another way to kind of check that out. So those are my 4 answers. I really have 0 twice. Sometimes you'll say it, sometimes you won't. You'll just say it once. Now, these are my x-intercepts. I'm going to plot them. Here's the -1, the 0, and the 3. It was positive, so that tells me my graph finishes pointing up. Now, here's normal, no funny business. But then, it's like I'm saying, go to the doorway, but then come back again. And then it goes like this. So, did I cut through that one? And we'll learn this all later. What extra? It's 0. That's the 0 for the label. So it's more like a W, yeah. And you see it's 4th power, so it bends more times than the others. Do you see it has more turning? Okay. Now also, x to the 2nd power. What kind of graph is x to the 2nd power? Starts with the P. Parabola, yeah. Do you see that by the 0 here? It looks kind of like a parabola. And then these are all x to the 1st power, and these look more like a line at their spots, like x to the 1st power. So that'll all tie together later, but don't worry right now. And the last example, 9, super fast. Number 9, hopefully before the bell, x squared minus 8x plus 7. Can anybody factor that in their head? What is it? What a queen. X minus 7 and x minus 1. It's a quadratic 2nd power. So how many answers? Ooh, am I cut off? I'm so sorry. It's 2nd power, so you're only going to get 2 answers. X minus 7 equals 0. X minus 1 equals 0. Am I going to get 2 answers? Yeah. X equals? And x equals? Good. So those are my 2 answers. Now guess what? Here's a cheap trick for graphing parabolas. How many of you guys forget how to graph parabolas all the time? How do you find the vertex? Do you remember? Okay, good. And then how do you get the y? Yeah, but sometimes it's a lot of work, right? What did I tell you these 2 numbers are for your graph? These 2 numbers are really your? Yes, zeros or x-intercepts. So I put a dot. It's positive x squared, so the graph will finish pointing which way? Up. Guess what I'm going to do? Cheap draw my parabola. Are you ready? Whee! That's it. Boom. Cheap trick done. So 2nd power means you have how many answers? There's my 2 answers. Your answers to your equation are also your x-intercepts. If your graph is positive, it finishes pointing upwards, and then you just cut it through. So you cut through. When do you bounce off of the x-axis? When do you bounce like this one? When does that happen?
It's 2 the same points.
Yeah, when you basically, if it's a double root, you bounce off the axis. So I'm going to share that with you. Now, fix it if you have mistakes. Give it to me tomorrow, and I'll give you a grade for it. So I know I just let you all walk out of the room, but you better all watch this because I'm about to make a correction. So we messed up over here because 2x squared, right, over x is 2x. And then negative 6x over negative 3 is also 2x. So I'm making a correction. So hopefully you guys all fix this in your work. So that's 2, it still matches. So then it's 2x plus 1 that came out front. And then that's 2x plus 1. And good thing I use the erasable pen and erasable highlighter. So I'm going to fix that for us. So I'm going to even go over here. Let's erase all this. So now I have 2x, equals negative 1, subtract 1 from both sides, divide by 2, so x is negative 1 over 2. We better all fix this, I hope. So negative 1 over 2, sorry my handwriting's a little weird with my 1s, and then my graph, I'm just not gonna have my graph to scale, but we'll do our best. I'm gonna go over here. I'm gonna say this is -1, so that's -1/2. Okay, so now my graph is accurate. Okay, so Moreau caught that mistake, and hopefully you guys will fix that in your work. Thanks very much.